Hello everybody, thought I'd fire up the camera and make a little video here, maybe some information that will be useful to someone who might have a problem. I want to preface this video by saying this is for entertainment only. I don't recommend that anybody just go around messing in the back of a monitor, because as I'm sure everyone knows, there are hazardous voltages in a monitor. So as Mr. Carlson would say, if you're following along, you're doing at your own risk. I can assume no responsibility for this. But this is for entertainment only, information, and trying to diagnose what is going on with this. I have no brightness control whatsoever. I've already repaired this deflection board, and the deflection board had, let me grab my glasses. The deflection board had crusty I hear that thing kind of doing a little pop, and I'm going to turn it off. I just removed the big resistors and jumped them. The linearity pot on the Y was partially open. I replaced that linearity pot, and that really brought this board back to life. But I had to put new fuses in it because the fuses were all crusty. That's pretty much it, I believe. I replaced all of the pin connectors. I don't know if you can see in there. See that black pin connector there on the bottom? I replaced all of the headers on this to make sure, verify it's get good connection. So the deflection board's good to go. This thing has an issue. It's actually got a couple issues. One, you can see where I've got these backed off a little bit. If you put those all the way on, they do not connect. These connectors are flaky and need to be replaced on both of these. You can see I've got it somewhat off. That's the only way I can get a continuity through that. So those need to be replaced. This one has been capped, but you saw when I had this thing running, and the high voltage control down there doesn't do anything, and the brightness control doesn't do anything. I've already verified that the deflection board's good, so that's not an issue. You know what I want to do is, now let's grab this. So take a look at this schematic here. This is the schematic, and the Z amp, which is the brightness amp on here, the Z amplifier can take the beam from 0 to full brightness, and right now it's just stuck on full brightness. There's no Z amplifier at all on this thing. So this is, and it's run on 90 volts from the high voltage unit. And I already, like I said, I already know that the problem is the high voltage unit, because I have another one of those that actually works, and it's not the deflection board, it's that. So I know that. And that Z amp is run off of 90 volts, and this is the high voltage transformer. And way up at the top of it is the, high tension AC. And right here, the first tap is 90 volts. That's where the 90 volts comes off to go to the Z amp. And then it comes up, and you got your focus voltage up here. It's around 400 volts, 380 to 400 volts or something like that. So that's for the focus and other, the grid and stuff like that on the tube voltages. And then this is the 90 volts that goes to the Z amp on the deflection board itself. So what I want to do is I want to verify, is this transformer good? Because I can, 90 volts is on, and if I look at this one right here, 90 volts comes off of pin 5. Pin 5 is that 90 volts. You'll see C907, the positive of C907 right there. That is the filter for that 90 volt line, C907. So yeah, if we come over here and we look at the schematic, right here is C907, and the positive is the filter for that 90 volts. So that's 5, pin 5. So what I can do, I want to put some other connectors on here so that I can just grab stuff. So let me do that and I'll be right back. Okay, so I'm hooked up now and we're going to check. See, you can see I got the red lead clipped to pin 5. That's the 90 volt out. And I got this just grounded. So when we fire this up, we should see, I'm on DC scale, we should see 90 volts. So I'll go ahead and fire it up. And there's no voltage at all. Okay. And we've got full brightness, remember? There it is. Let's go ahead and turn it off. Now what I want to do, okay, I've got nothing here. What about right here at the anode of 901? You can see the circuit here is through ground to here. That's the circuit for that AC. So I'm already connected to ground, so if I probe the anode of D901, I should see 90 volts AC or around that. So what I want to do is remove this, okay, and actually just remove that and get my red pointer lead, plug it in, okay, and here's D901 right here, okay. So right there, the anode of D901 is what I want to probe. So let me go ahead and set the camera down and hold this and put my scale on AC. And really quickly, I'm going to fire this thing up. And you can see it reading 74 volts AC. Go ahead and turn it off. And I kind of wonder, let me be right back. I am going to get a better ground. Alright, well, we saw about 75 volts or so AC at that point, which I would think it would be a little higher than that, but that seems to be just what it is. Anyway, I've got this thing on a better ground now. And I want to switch over to DC. And we should at least have, right here, we should at least, at reference ground here, we should at least have 80 volts or so. As you know, rectified voltage is always higher than the AC for whatever reason. So we'll probe here on DC meter at the cathode of 901, which is right there. Yeah, kind of hard to do one-handed. Let me get the tripod. Okay, there, I have this on DC volts now, and I'm going to probe that cathode of 901, D901. Let me get in on it. Okay, I'm on that cathode, so I'm going to go ahead and fire it up. And you can see there's no voltage there. Alright. That means that diode is open. D901 is open. This guy right here. And just for shits and giggles, let's put the other working one on there and do the same test. Okay, on this one I am probing the pin right here, 5, which is, it's supposed to be 90 volts, I thought. But we're reading 65 volts basically, which is a little weird, but whatever. And on the anode side of D901, when probing that, I'll have to come back, I'll have to cut away, but it's like 23 volts. So I'll go ahead and cut away and I'll be right back. Okay, well, I've done enough messing around with that. The bottom line is, on this one we have about what looks like 25 volts. On the anode, I don't know, maybe I'll try one more time. Try to get a good ground. Come on. Try that. And I will try to get a AC signal here. Okay, let's go for it. Yeah, 25 volts AC. And move over to DC and just try to okay, let's see if we can get a 65 volts DC on the cathode side. And remember, on the other one we got nothing on the cathode side, so I'm suspecting D901 or something else shorted, pulling it to ground. Maybe it's this 4.7 microfarad cap. We'll have to just take a look at stuff. Alright, well, I took some parts out of this thing. I've been testing some parts. And this thing right here, this little pot is no good. This is a 5K pot. And let's see if I can just, I don't know if I can do this. You'll see. And tripod time. Okay. And alright, let's grab this. Let's grab this. First, I'll just measure across the carbon track itself, the resistive track itself. And you see it is 5K. Now if I leave my probe on one side and go down to the wiper, I get 10K. And if I go to the other side, I get over 5K. It's just kind of a weird up to, it's just crazy. This pot is no good. It is definitely it's a 5K pot, but it's just no good. And I've been finding that these pots like this are junk. So I'll put a new 5K pot in it, and that might be the whole issue. I kind of want to find, it's got to be in the regulator circuit. It is high voltage adjust, and that goes, interesting, 62 volts. Let me grab the thing. High voltage adjust, and we get 62 volts. Now this thing is going to be, okay, this is a regulator circuit, and this sets the emitter bias at 9.1 volts. And the base goes to the wiper, comes from the wiper. And it looks like 62 volts is interesting. That's in reverse bias. So 62 volts would be right here, which isn't going anywhere unless it's AC, because it will not, AC, the DC current will not pass through this. So where's this going? We have 62 volts right here. And remember, I read 65 volts or something like that. Where does that go? Is that coming right here? I don't know where this goes. 901. I'm just going to have to trace it out on the board. I'll be right back. Alright, well, I put this thing back together. I got a new pot in there. Now, I don't have any... Mute that. I don't have any 5K pots like this, so I used a 10K pot, and I put a 4.7K across it. And what that does is it basically divides the resistance in half. I put the other diodes on the back side, because I figured it'd just be easier because the solder is so terrible. These parts tested fine. And this is in that 62 volt circuit. I don't know if you can tell. Right here where it comes off of there, it goes through, and there's that 62 volt Zener diode. Yeah, so we'll hook it back up and see if it makes a difference now that we've got regulation on the high voltage. Because we didn't have any, that pot was bad, and that's in the regulation circuit. So, the high voltage regulator. So that could have been the whole problem. And if we weren't getting anything from wiper to down here, that would maybe explain the 0 volt situation that we had. I don't know. We'll see. Alright, well, I've been doing a lot of messing around on this thing, and unfortunately this one has a bad transformer. You can hear it internally arcing, and I think it's getting ready to self-destruct. I replaced the just to do it, to make sure. That's a fast switching 1 amp 400 volt diode, D901. I replaced that cap, and the cap that was on there looked a little bit suspect, honestly. Come on, am I going to focus or what? Anyway, that thing looks a little crusty. But I'll turn this thing on, and it's getting worse and worse and worse. It's really starting to snap and crackle. Hear it? I'm going to go ahead and flip this thing over carefully. Set the camera down. And set it down like so. And let's turn it back on. And it's just super snap, crackly, poppy. I think what's going on is that winding is so bad, it's really snapping. I think that it doesn't have enough current behind it at all to even drive that diode. Yeah, that thing's getting ready to blow up. I'm going to turn it off. Yeah, it's dead. Unfortunately. So, alright, yeah. Something in there is snapping. I believe it is the transformer itself. And it stinks. Alright. No fix. And this just proves the fact that this transformer is no good. Remember on the schematic, let me get this viewfinder, whatever. Okay, remember the schematic, pardon me, says that there is a winding right here from ground to the point that goes to the anode of D901. There's a winding there, circuit. So if I take on ohms mode and go to the ground and then go to the lead of the transformer that goes to the anode of D901, you see we get 3 ohms, which is an extremely low resistance. That's that winding. Now if I look at our bad, our one that doesn't work, and go to ground and then go to that lead, we're up in the mega ohms and climbing. Yeah, that winding is, it's looking like it is internally no good, and that's why it just won't drive that diode. That's why we have voltage on one side of it, because we have some resistance. If we have some kind of resistance, we'll have some kind of voltage going through there. But there's just not enough behind that winding. Once it loads that diode, it probably just opens right up. It's basically almost open right there. That's it's extremely high resistance. So this transformer is just no good, unfortunately. Unfortunately, it's just dead. That's unfortunate. Yeah. Well. Yeah, I don't see, I mean, I can see the lines going to it. Wait a sec. That is, hold up a second. What's going on here? There's a broken line right there on the transformer. And lo and behold, it is, there's a broken lead on this transformer. I can fix that. Let me grab this. Okay, down. And that's one of the grounds. You can see it right there. That wire right there is broke. And that is one of the grounds. That's probably the other side of the winding to that one right there. Those two are probably that winding, because this one goes to ground. That's probably what was snapping. So I'll see if I can't, I got to remove this thing, I think. I'm going to have to remove the transformer and try to repair that. And that might fix the thing. Okay, to accomplish this, I've gotten the big dog out. The great big lead, or great big soldering iron. Yeah. It's going to be tough to get this out of here. It'll be really tough. Okay. Well, that cleared that pretty good. That won't go over that, but I can melt it really good. Oh, one more. Let's see where we're at. Okay, we're not quite there yet. I don't want to be forcing anything, so let's clear off a little bit better around here. Alright. That's got that pretty good, I think. Okay. Let's clear all of these a little bit better. Okay, good. Okay. try these a little bit better. Okay, I really think that should do it. Huh. Let's try breaking these free a little bit. There we go, I think it's coming now. Yeah, just a couple over here. I think these... There we go. Thank you so much, Mr. Desoldering Gun. Thank you so much, Mr. Soldering Iron. And we'll put you up. I'll be right back. Okay. There's the broken wire. You can see it right there. And that is one of the ground lugs, so that's probably a winding right there. So I'll go ahead and reattach that. And we'll ohm out from here to here after I've reattached that, and it should be about 3 ohms, hopefully. Okay. So I had to kind of tack solder these together. I don't love it, but can't really get a good mechanical connection on that, but it's a good solder connection, I think. And if we take and measure these 2 leads, we now get 3 ohms. And sometimes I lose connection, but it's 3 ohms. So that is repaired. You know, yeah, it is what it is. So let's go ahead and put this thing back together. Okay, got it all installed, and we are still at 3 ohms. So in theory, we should be good to go, because we diagnosed that we couldn't even drive this diode. The diode wasn't open. We just couldn't drive it. But this pot, that pot was 100% bad, because I tested it with putting an ohm meter with clips on it really good, and it would just go crazy up to like 30 mega ohms, and it had dead spots in it. So that pot was terrible. So I've repopulated this thing. I got to hook up the high voltage diode and hook it back up. Another thing of note that I did do is I replaced that connector. And I put a new insulator and heat sink paste on this the transistor. Transistor tested good, so it's not an issue, but I was getting flaky readings on the connector, so I just replaced it with this 0.100 pitch connector. So I got the diode hooked back up. Let's go ahead and hook this up. Okay, we're all hooked back up. So let's give it a shot. Well, look at that. We have Z amplification again. And we should be able to adjust the brightness. Yep. There you go. What is that noise? Thought I heard a noise. I don't know. Anyway, it's running, looking perfect. So what I'm going to do is just go ahead and let this thing sit here and work. Yep. Well, there you go. High voltage unit repair. Turns out the transformer, it was showing like it had a bad winding. Well, it did have a bad winding. It was broken. The wire was broken off. So just reconnected it, and there you go. Yeah. All right. Thanks, guys. See you on the next one.